Today our topic is complex number from class 11 and in which here we discuss modulus. Modulus of complex number. Modulus of complex number, first here we define modulo of complex number, that is here we consider a general equation like z equal to x plus iy, and it is denoted by mod z, two vertical lines between there here, and defined by as mod z equal to under root of x square plus y square. X square plus y square means here you write down the real part of z, that is x of whole square, and imaginary part of z of whole square, and then this is the definition of modulus. Okay, for example, now here we let's take one example like z equal to 3 plus 4i, and then how you find modulus z? Modulus z equal to this value square plus this value square without I only. You taking the imaginary part, it means accept I, you write down this value of whole square. So 3 square is 9, 4 square is 16, 9 plus 16 is 25, 25 square root is 5. Similarly, that is, suppose here both values are in positive but both values are in negative, so there is no change again. Minus 6 of whole square and plus minus 8 of whole square. Again you have 36 plus 6, 64, that is 100, and 100 of square root is 10. Okay, maybe another question here we discuss like z equal to 3 minus 5y. Okay, so mod z equal to under root 3 square plus minus 5 of whole square. 3 square is 9 plus 5 square is 25, and then you have 34. Okay, this is also a part of modulus. Similarly, here we have the example for like z equal to root 2 plus I. Okay, coefficient of I is 1 here, so mod z, you write down like root 2 of whole square, and here 1, so you write down 1 of whole square, and then 2 plus 1 is root 3. Okay, so this is the modulus of z, and now here we discuss like 4 questions in which we find the modulus. And modulus is very easy, only you do the complex number, first value of square and the second value of square, plus sign minus sign given, that is doesn't matter because the square of whole term, and minus you taking the whole square, that is also plus, and plus square is already plus here. So 4 examples they are related with the modulus. Now here we discuss about the properties of modulus. Some properties here we write down with the help of general form, like here we discuss z, and z is always here you consider x plus iy, and z1 is x1 plus iy1, z2 equal to x2 plus iy2. Okay, now here we discuss like z, z1 and z2. There are 3 complex numbers here we discuss as a general form. And now first property is modulus of z equal to 0. It means the complex number is 0. Complex number is 0, it means real part of complex number is 0 and imaginary part of complex number is also 0. Therefore modulus of z equal to 0. And now the second property is like mod z equal to z conjugate. Mod of z conjugate. Because both are the same, now here we show out like example 3 minus 5 pi or 3 plus 5 pi, both values have the same answer, under root 34, under 34. So modulus of z and conjugate of modulus again same. And now mod z of whole square, which is equal to z into z bar. Bar means conjugate. So complex number and multiple of conjugate of complex number, that is a modulus of whole square. And now here we discuss like 2 complex numbers z1 and z2. They are multiplied, and then you separately find out their modulus and then multiply. Their result will be same. Okay, and then in case of the division, z1 upon z2, you first whole taking modulus, or you separately find out mod z1 upon mod z2, that is again your answer will be same, in which here z2 is not equal to 0, because in z2 is 0, then your complex number or your resultant value is not defined. Okay, so these are the 5 properties. Now 6 is again here we discuss like z1 plus z2 whole modulus of whole square, that is z1 square plus z2 square plus 2 real times of z1 z2 bar. Okay, that is so we have to prove here with the help of examples, with the help of algorithm. And the same property for minus, again you taking the same, and condition is same. Now here a plus b of whole square, so plus sign here, a minus b of whole square, so minus 2ab here. Okay, and now you adding 5th, 6th and 7th property, and then this part are cancel out here, you have this much only, and this is 2 times of z1 square plus z2 square. And the last property is, if you have any scalar term multiple of z1, any other scalar term multiple of z2, and whole value you write down with minus sign here of modulus whole square, and bz1 plus az2 of whole square, that is a square plus b square into z1 square plus z2 square, where a b are belong to real numbers. Real number, it means they are maybe any scalar value, and then you find out with the help of property. So one by one here we prove, like first property, second property, third property and fourth property, how you got the value, because just here to sort like 9 properties are here, so 1 or 2 properties here we show out, and then results are equal there. Okay, then first property is your modulus of z, that is 0 when if z equal to 0. So z equal to 0, it means 0 plus 0i, and then you find its modulus, that is 0 square plus z square is again 0. It means your real and imaginary both are equal to 0 here, therefore we got mod z equal to 0, therefore your real, complex number also will be 0. Okay, then the second property is mod of z equal to conjugate of complex number of mod is again both are value are same. So here we consider like z equal to x plus iy, and then its conjugate is x minus iy. Now here we find the modulus of this complex number, that is x square plus y square, and now here we find out mod z bar, which is equal to under root of x square plus minus y of whole square, that is under root of x square plus y square. Okay, so implies mod z equal to z bar. Okay, so second property also proved, and then third, that is mod z square equal to z into z bar. Okay, so again here we consider the same, z equal to x plus iy, z bar equal to x minus iy, and then here we find out like mod z, which is under root of x square plus y square. Okay, squaring on both the sides, then mod z whole square, and here under root of x square plus y square is also whole square, so that is x square plus y square. Okay, this part is like you have left hand side. Okay, and then we have the right hand side, z into z bar. Okay, so x plus iy, and now here add on x minus iy, first value of whole square minus second value of whole square, so x square minus I square y square, x square of minus 1 y square, x square plus y square. Okay, so this is the right hand side, and now both are equal, right hand side equal to left hand side. Okay, so this is very easy going. Now you discuss like all the properties are related to the same, and now you same consider and same proof, because here we discuss like the same like z1 z2. One more property here we prove, because z1 z2 is the different form, and then we show out like the whole concept is like same, because all properties they are related with the z1 z2. So one property here just prove for 4, and then they are all according to the 4 you have to prove, because z1 and z2 we know that x1 plus iy1 and z2 equal to x2 plus iy2. So these all are very easy properties, and now you do the algorithm process and then start the questions, like maybe different numeric value with the given, and then you apply these properties. Okay, then we have z1 and z2, like here we consider the same. z1 is x1 plus iy1 and z2 equal to x2 plus iy2, and now we have to show that this property number 4, because all properties related with the z1 and z2. So for example only this property can be proved, and then according to same they are related with the same. z1 z2 equal to mod z1 into mod z2. how it is proved. So here we have the example, like first we have to show that modulus of this product equal to, separately they are find out with the modulus. Z1 x1 plus iy1, z2 equal to x2 plus iy2. Okay, now here we find out first z1 into z2. Before our modulus, first we find out the product of this two complex number, x1 plus iy1, x2 plus iy2. Okay, then x1 x2 x1 y2, here we write down iy1 with x2 and iy1 iy2 I square y1 y2. And since we know that here I square is minus 1, okay, so here we substitute this value, I square is minus 1, and now x1 x2 as it is, and in both values here I is common, so I outside, x1 y2 x2 y1, then minus y1 y2 because I square is minus 1. And now we have to separate the real and the imaginary part. X1, x2 and y1, y2 both are the real. So you write down combined here, and then here you have write down this. Okay, so now the product is convert a general form of the complex number. Now here we find the modulus of this product. So under root of real value of square plus imaginary value of square, here you write down with plus sign. Okay, and then now we continue on the right hand side. We have mod z1 and mod z2. So separately here we find out mod z1, that is under root of x1 square plus y1 square, directly it is given here. And now z2 equal to under root of x2 square plus y2 square. But now on the right hand side z1 into z2 is given. So you have the right hand side z1 into z2. So here we multiply these two square root numbers. And now root a, root b, that is root ab. So they are multiplied inside. Now this bracket multiply by this bracket. So here we explain x1 square, y1 square, x2 square, y2 square, we multiply, and then we have four terms inside here. Because x1 square, x2 square, x1 square, y2 square, y1 square, x2 square, y1 square, y2 square. Okay, then now again this value and this value are not matched, but now here whole square is given. So after simplification of whole square, so again we add down this bracket and then whole value. And now open the bracket, like here a minus b of whole square, so a square plus b square minus 2ab, and here a plus b of whole square, that is a square plus b square minus plus 2ab. So plus 2ab and minus 2ab both value are same, so they are cancel out. X1 square, x2 square plus y1 square, y2 square, x1 square, y2 square, x2 square, y2 square. Now both values are same. It means RHS and left hand side and the right hand side now both are equal. So that is very easy concept only in behalf of the algorithm, maybe their procedure is lengthy going, but you have the numeric value again very easy, because like some numbers you multiply and then you have the particular one solution there and then you write down the results. So these all properties they are related with the modulus of complex number, and now these all are property are very easy going. Only in the competitive exams this type of property may be asked in the examinations, but like in your MCQ type variety of the question also may be asked there this property, and you try with some numeric value. This all property you thinking like Z1 any numeric value of complex number, Z2 also you consider the same, and then you put value and then you check or verify.